All right, so here we go with objective 2, which is solving linear equations with integers. So in math, we talk a whole lot about expressions, equations. We use those words a lot. So I want to start off by just defining exactly what an equation is and what an expression is. An equation, we know something is an equation because it has an equal sign, right? We see that in the word equation, you kind of see the word equal. In other words, the equation has both a left and a right-hand side. Right? There's an equal sign, so there's a left side of that equal sign, and there's a right side of that equal sign. An expression does not have an equal sign. Okay, so let's take a look at some of these examples here and determine whether or not they're expressions or equations. This first one here, I don't see an equal sign. There's plus, but no equal sign, so this is an expression. This one here, I do see an equal sign, so this is an equation. This next one also has an equal sign, so this is also an equation. This last one, there's plus and there's minus, but there's no equal sign, so this is an expression. Let's talk about this next example. Here I want to consider what's missing in the box in this equation. I have a box plus 2 equals 7. So I'm thinking to myself, something plus 2 equals 7. What plus 2 equals 7? So think about that. 5 plus 2 equals 7. So we can say that 5 is that missing box. So 5 is that missing box. So 5 plus 2 equals 7. And you can double check, does 5 plus 2 equals 7? It sure does. So this is useful in other examples. Of course, we know off the top of our head 5 plus 2 equals 7, but suppose that I had a more complex example like box minus, say, 98,758, and we're saying that's equal to, I don't know, 5,994,362, right? This becomes a little bit more difficult to do in our head. So this is where solving equations comes in handy. So let's jump down here, solving one-step linear equations with integers. So when we're solving equations, our goal that we have in mind is to get the variable by itself. So when we're looking at equations, of course, we can talk about variables. As a reminder, variables are just letters that we use in place of unknown quantities. So looking back up here, instead of this box plus 2, we don't know what the box is. We could say we have a variable x plus 2 equals 7. And this looks more like an algebraic equation. So our variable here is x. We want to get x by itself. In order to get it by itself, we have to do the opposite of what is in the equation. So do the opposite of what is in the equation. So what do I mean by that? If we have, say, a plus 4 in the equation, we want to do the opposite. We want to do a minus 4. If we have a times 10, we want to do the opposite. We want to do divided by 10. So how do we know what operations to do and in what order? We're going to go in reverse PEMDAS. And if you remember PEMDAS, remember, please excuse my dear Aunt Sally. We want to go in reverse order. So we're going to start with addition and subtraction. And then we're going to look at multiplication and division. And then we're going to look at exponents and parentheses. So we're going to go in reverse PEMDAS. So let's take a look at this equation here. We have 2x plus 4 equals 18. So looking at reverse PEMDAS, I want to start with addition and subtraction. I see here that we have plus 4. That's addition. We want to do the opposite of what is in the equation. So instead of plus 4, we're going to subtract 4. Now, if we subtract 4 to this left-hand side of the equation, we also have to subtract 4 from the right-hand side of the equation. The reason why, you can think of it as a scale. If I were to add or remove something on one side of the scale, in order for the scale to balance, you have to do it also to the other side. So let's put a note in here as well. If you do something to the left, you also have to do it to the right. And use exclamation marks, use stars. This is very important. If you do something to the left-hand side, you must also do it to the right-hand side. And of course, vice versa is true. If you do it to the right-hand side, you must also do it to the left-hand side. So looking at this here, on the left-hand side of the equation, well, I see we have a +4 and a -4. Those cancel out. So all that's left on the left-hand side of the equation is this here, the 2x. That's all that's left. On the right-hand side of the equation, we have 18 minus 4. Well, 18 minus 4 is 14. And then we'll just bring down our equals. Next up, I don't see that we have any more addition or subtraction, so now we can take a look at multiplication and division. Do we have any multiplication or division here? I see that we have 2x. Remember, anytime you have a number times a variable, there's multiplication happening in between there. We have 2 times x. So in order to get rid of 2 times x, or multiplication, we have to divide by 2. And if we do it on the left-hand side, you must also do it on the right-hand side. So we're going to divide both sides by 2. So on the left-hand side, we have 2 divided by 2. That's just 1. That cancels out. That's the whole point of doing reverse PEMDAS, the opposite of what's in the equation. So all that's left is this x here. And then on the right-hand side, we have 14 divided by 2. Well, 14 divided by 2 is 7. And we bring down the equal sign. So we have x equals 7. Did we achieve our goal? We sure did. We got the variable by itself. So we always check our work just to check and see if we got the right solution. So you can write check. In order to check your work, take your solution and plug it back into the original equation. So here we have x equals 7. We're going to plug in 7 for x in the original equation. So when we're checking, we have 2 times x, so we can plug in 7. 2 times 7 plus 4 equals 18. And then we can just evaluate the left-hand side. We have 2 times 7 is 14, and then bring down the +4, the equals, and the 18. Again, we have 14 plus 4. Well, 14 plus 4 is 18, and then bringing down the 18, the equals. Does 18 equal 18? It sure does, so that means we did it correctly. Let's flip it over to the next page. So here I've got 2 more examples. You can try them on your own. So go ahead and hit pause, try them, and then you can check your answers when you're ready. So looking at this here, I'm going to first start by writing PEMDAS up here at the top just so that we don't forget. And then remember, we're going in reverse order. So we're going reverse PEMDAS. We're going to start with addition and subtraction, then multiplication and division, then exponents and parentheses. So looking at this here, starting with addition or subtraction, do we have any addition or subtraction? I see we have -8. Now remember, in order to solve, we have to do the opposite of what's in the equation. So instead of -8, we're going to do +8. And if we do +8 to the left-hand side, we have to do +8 to the right-hand side. The left-hand side, the -8 and the +8 cancel, so all that's left is 3a. On the right-hand side, we have 19 plus 8. Well, 19 plus 8 is 27. And we bring down our equal sign. Any more addition or subtraction? I don't think so. So then we've got multiplication and division. Here we have 3a, which means 3 times a. So in order to get rid of the times 3, we have to divide by 3. do the opposite of what's in the equation. So then, this 3 over 3 cancels. We're just left with 1a, or just a. And on the right-hand side, we have 27 divided by 3, which is 9. We have the variable by itself, so that is our final answer, a equals 9. We're going to check our work. So we have our original equation is 3a minus 8 equals 19. So plugging in 9 for a, we have 3 times 9 minus 8 equals 19. And by the way, it's good practice whenever you're substituting back in to substitute it in with parentheses. So we have 3 times 9, which is 27, and then we'll bring down the rest. So minus 8 equals 19. 27 minus 8 is 19, and bring down the rest equals 19. Well, does 19 equal 19? It sure does, so we did that correctly. Our last example, here we have negative 4y plus 7 equals 23. The first thing we do is I see addition, so we're going to do the opposite, subtraction. So on both sides, we're going to subtract 7. So the plus 7 and the minus 7 cancel. All that's left is the minus 4y. And then we have on the right-hand side, 23 minus 7. Well, 23 minus 7 is 16. We'll bring down the equal sign. Now we have negative 4y. That's the same as saying negative 4 times y. So our next step, we want to divide. But one thing that a lot of students forget is this negative out in front. We have negative 4 times y, so we have to divide out negative 4. A lot of students will put positive 4. Remember that negative. And if we do it on the left-hand side, we must also do it on the right-hand side. So then the negative 4 and the negative 4 on the left-hand side cancel. All that's left is y. And then on the right-hand side, we have 16 divided by negative 4. Well, a positive divided by a negative is a negative, and 16 divided by 4 is 4. So y equals negative 4. So let's check and see if we got that right. So plugging it into our original equation, we have negative 4 times y, or times negative 4, right? We're substituting in from our solution, plus 7 equals 23. Negative 4 times negative 4, that's a negative times a negative, is a positive, and then 4 times 4 is 16. So we have positive 16. Plus 7 equals 23. I'm just bringing that down. 16 plus 7 is 23. Bring the rest down, equals 23. And 23 does equal 23, so we did that correctly. This is Objective 2. We're going to get a whole lot of practice on this. Have a great day, everyone.